In the intricate web of technological advancement, programming languages stand as the architects of our digital realm. These languages, evolving in tandem with the ever-changing landscape of technology, have not only shaped the way we communicate with machines but have also influenced the very fabric of human progress. The history of programming languages is a fascinating journey, a tale of innovation, challenges, and triumphs that has unfolded over decades. The roots of programming languages extend back to the 19th century with Charles Babbage's visionary concept of the analytical engine. Although Babbage's machine was never fully realized during his lifetime, the idea of a programmable computing device laid the groundwork for future endeavors. The early 20th century saw the emergence of punch cards and plugboards, precursors to modern programming. Pioneers like Ada Lovelace, often considered the world's first programmer, envisioned a future where machines could process symbolic instructions beyond mere arithmetic. The first true programming languages were in essence, machine code and assembly languages. Programs were written in binary, directly instructing the computer's central processing unit, also known as the CPU. Although challenging for humans to work with, they formed the basis for higher-level languages. Assembly languages provided a more human-readable abstraction of machine code, making programming slightly more accessible but still highly complex. In the 1950s, the landscape shifted with the creation of Fortran. Developed by IBM for scientific and engineering calculations, it was one of the first high-level languages, showcasing the potential for abstraction and laying the groundwork for subsequent languages to build upon. This breakthrough allowed programmers to write code using more human-friendly syntax, paving the way for broader adoption and collaboration in the scientific community. Simultaneously, John McCarthy developed LISP, or Lisp processing, at MIT, aiming to create a language specialized in symbolic computation. LISP became instrumental in artificial intelligence research and introduced the concept of garbage collection, laying the foundation for modern memory management. As computers found applications beyond scientific and engineering domains, the need for business-oriented languages arose. COBOL, or Common Business-Oriented Language, was developed in the late 1950s to address this demand, providing a language specifically designed for data processing and business applications. ALGOL, or Algorithmic Language, emerged as an international effort to create a universal programming language. Though not widely adopted for practical programming, ALGOL influenced future languages and played a crucial role in the development of structured programming concepts. The 1960s witnessed a shift towards structured programming, emphasizing modular design and code readability. Languages like Pascal and Ada embraced structured programming principles, promoting the use of functions and control structures to enhance code organization. In the early 1970s, Dennis Ritchie and Brian Kernighan developed the C programming language at Bell Labs. C's simplicity, efficiency, and portability made it a cornerstone for operating systems development. The Unix operating system was developed in C, showcasing the language's power, and its influence can be seen in many modern programming languages. C's influence extended far beyond Unix, becoming the foundation for later languages and systems. The iOS and Android operating systems are Unix-based. Smalltalk, developed at Xerox PARC in the 1970s, introduced the concept of object-oriented programming. Smalltalk's innovative approach of representing entities as objects, each with its own state and behavior, revolutionized software design and laid the groundwork for object-oriented programming languages to come. Bjarne Stroustrup's creation of C++ in the early 1980s marked the fusion of object-oriented programming with the efficiency and power of C++, provided a bridge between procedural and object-oriented paradigms, becoming the language of choice for systems programming and application development. Guido van Rossum's creation of Python in the late 1980s aimed to develop a language that was easy to read, write, and understand. Python's versatility, combined with a vast ecosystem of libraries, made it a popular choice for various applications, from web development to scientific computing. Its simplicity and extensive libraries have contributed to its widespread adoption, making it a language of choice for beginners and experienced developers alike. Yukihiro Matsumoto designed Ruby with a focus on simplicity and productivity. Ruby embraced object-oriented principles and introduced elegant syntax, attracting a dedicated community of developers. Ruby on Rails, a web framework built with Ruby, revolutionized web development by emphasizing convention over configuration. In the mid-1990s, James Gosling and his team at Sun Microsystems created Java, a language designed for cross-platform compatibility. Java's "write once, run anywhere" mantra, along with its strong emphasis on security, propelled it to dominance in enterprise applications and laid the foundation for the Android operating system. Brendan Eich's creation of JavaScript at Netscape in 1995 transformed the landscape of web development. Initially conceived as a scripting language for enhancing web pages, JavaScript evolved into a powerful, versatile language, enabling the development of complex web applications and server-side scripting through platforms like Node.js. Functional programming gained prominence in the late 20th century, emphasizing immutability and the use of functions as first-class citizens. Haskell, a purely functional language, and Scala, a language blending object-oriented and functional paradigms, showcased the advantages of functional programming in terms of conciseness and expressiveness. Go, developed by Google in the early 21st century, aimed to combine the efficiency of systems programming languages with the simplicity of modern languages. Go's built-in support for concurrent programming and efficient compilation made it a popular choice for scalable and distributed systems. Rust, developed by Mozilla in the 2010s, focused on providing a safe systems programming language without sacrificing performance. With its emphasis on memory safety and zero-cost abstractions, Rust gained popularity in fields like systems programming, game development, and embedded systems. Apple's introduction of Swift in 2014 marked a significant departure from Objective-C. Swift combined the best features of modern languages with seamless interoperability with existing Objective-C code. Its ease of use and performance made it the language of choice for iOS, macOS, watchOS, and tvOS development. The history of programming languages is a journey of continuous innovation, adaptation, and expansion. From the binary instructions of early computers to the sophisticated languages of today, each milestone in programming language development has shaped the way we build, communicate, and interact with technology. As we stand on the cusp of the future, the tapestry of programming languages remains unfinished, with new languages and paradigms yet to be woven into the ever-evolving narrative of code. Do you know other programming languages that were worth mentioning? Please comment below and share your knowledge. Thank you for watching, and please don't forget to like and subscribe.